Welcome to the first part of this course. During this part, the objective is to develop some intuition on how electric circuits work. I will explain you in broad terms how the basic components of a circuit work, and later in the course we will learn them in more detail. We will study a very simple circuit consisting of three components: a resistor, a capacitor, and a voltage source. This circuit is usually called RC circuit because of the resistor R and the capacitor C. Here you can see a diagram of this circuit created with the symbols available in System Modeler. Here we can see the resistor, the capacitor, and a voltage source. If you have seen other electrical diagrams, some of these symbols may look familiar to you, but there exist other versions of the same symbols. Here you have a few examples for the resistors, capacitors, and voltage sources. In the diagram, we can see that there are lines representing connections, like this and this. These lines are equivalent to physical wires connecting terminals of the components. These components are connected in a loop from the voltage source to the resistor, and from the resistor to the capacitor, and then back to the voltage source. We have a special symbol called ground. This is a special component that is necessary in all circuits, but for now we will ignore it. The RC circuit, as simple as it looks, it has a lot of practical applications. One of them is acting as an audio filter. A filter is a device designed to eliminate specific aspects of the sound. For example, a blanket can act as an audio filter. If you cover your head with a thick blanket and you speak, the person in front of you will hear your voice muffled or softened. Let's listen to an audio example of a signal being processed with a filter. Here you can listen to the signal without any filtering. It has a harsh and synthetic sound. And using this slider, we can control how strong is the filtering. You can hear that the sounds becomes softer because we are removing higher frequencies. If we change over time the filter, we can dynamically affect the sound. For example, this one. It sounds like a cheap toy piano or a guitar. The sound starts louder and it gets softer as it progresses. Let's go back to the RC circuit. Here we can see the simulation results. In orange, we have the input voltage, which is a constant source of 1 volt. In blue, we have the voltage of the capacitor. We can see that it starts from 0 and it rises until it reaches a value of 1 volt. This is similar to what happens when you charge your phone. You start with a low state of battery and it rapidly increases. But the last 20% always seems to take longer. The way the circuit works is the following. In the beginning of time, the capacitor is completely discharged and the battery starts providing energy that flows through the resistor and starts accumulating in the capacitor. At some point, the capacitor has the same voltage as the input source and the circuit is in equilibrium. We can see that it takes around 0.5 seconds to charge. It takes specifically this amount of time because of the values that we have selected for the components. The resistor is 10 kilo ohms and the capacitor is 10 microfarads. We can experiment with different values and see how they affect the results. First, let's increase the value of the resistor. As you can see, it takes more time to charge. That's because a larger value of resistor resists more to the flow of energy. And if we make it smaller, we expect that the energy will flow better and the capacitor to charge faster. And what will happen if we change the capacitor value? As we make it larger, it takes more time to charge. Similarly, when the capacitor is small, it charges faster. One analogy to understand capacitors is to imagine them as buckets. If you are filling them with a steady stream of water, the bigger bucket will take more time to fill up compared to the smaller one. Here is a short summary of this lesson. You were introduced to the basic RC circuit, which consists of two main components, a resistor and a capacitor. The circuit has many applications, and one of them is as an audio filter. Its behavior is defined by the component values. The larger the capacitor and the resistor, the longer it takes to charge. In the following lesson, we will start learning one of the fundamental principles of electrical engineering, which is the Ohm's law. This is what describes what happens to this circuit when changing the resistor value.